Alright, so let's take a look at what it would mean to actually plot some of these curves using some technology. And so the program that we'll use is called Geogebra. Now there's a couple of different ways that we can plot these curves with Geogebra. The first way is really just with the curve function. So if we brought in curve, then the arguments for that function, well, the first argument is going to be our x-coordinate. So that was our cosine of t. Our y-coordinate, let's make our y-coordinate sine t, and then the next argument is our parameter variable t, and after that we tell Geogebra that we want t to start at 0 and we want it to go to 2 pi. So when we do that, here's the image that we get for our curve. So that kind of gives us the whole image. It doesn't necessarily give us the orientation or our parameterization for that. For that, we can do a different kind of thing that we can do. So we kind of want to declare our parameterization variable, and we'll do that as a slider. So we'll do it as a slider, and we'll call our variable t, and we want our t value to go from 0 up to 2 pi, and let's increment it at 0.1. And then for the animation values, we don't want it to oscillate. Let's just say that we are just increasing one time for that, so we can get an idea of how this one actually goes. Okay, so we've got our variable t. Now if we want to plot our function, we can say that we've got a vector v, and that thing will be a vector. And so now for vector, we'll take a point, and for that we'll just put in our point with our cosine of t and sine of t being our values that we have in there. And so we can see that what happens, let's kind of stop that animation. What happens then is that we have this vector. Let's kind of change that color and make it red so that we can see it a little better. So now we've got our vector v that is our position vector. So our point starts at 0, 0 and goes out to our point on the curve at time t equal to 0. Then as t increases, we can see what happens with our vector. Now our vector actually changes with time. And so if we want to see how that runs, take it back to the beginning, and we can turn our animation on. And so we get the value for t increasing from 0 up to 2 pi, and we see that it's pointing to every point on our actual curve. So hopefully this gives you a little bit of a taste of how we can use Geogebra to plot some of these vector valued functions. Now if we wanted to do something similar in 3 dimensions, what might that look like? Well, I can go up to view. I want to do a 3D graphics for that one. So let's say that I'm finished with this one. We have our original curve down here in our XY plane. Let's say we'll do another curve now. We'll make it a 3-dimensional curve. How about a cosine of t, sine of t with t and regular t for our z value, and then we'll make it as t goes from 0 to let's do 4 rotations, so let's say times 8 pi with that one. Okay, so when we do this, we can see what happens with our curve. So let's get rid of our original curve here. We don't need him anymore. And we don't need our vector there. Delete that. And so what happens, we see that we have our vector in 3 dimensions, and what this does, we get our curve that's kind of spiraling around the z-axis for that. And we can do a similar thing if we wanted to do a vector out of that. So let's say that we have a vector w, and that's going to be a vector from our point cosine of t to sine of t and t for that value. And let's make that one also red, so he's kind of showing up as we can do that. So now for our value of t, so this was our slider that we had. And so as t would move, if we make t a value of 1, we get pointing to the vector that's down here. If we had a value of 3, now we're up to that point. A value of 5 gets us up to there. And so you can see that as we're doing this, we have just these position vectors from the origin out to the particular point on the curve, just like we talked about in the previous video. So again, I hope this gives you a little bit of insight into how we can plot these things in 2 dimensions as well as 3 dimensions using GeoGebra. I'll see you guys next time.